This is lesson 12, ways to compare fractions. So, the warm-up for this is what's the point? If you look at this number line, you can easily see that there's a 0 and a 1. However, there's no tick marks in between, you'll notice. So, you would need to kind of think and estimate about where on this number line do you think this point is. We don't know exactly because we don't have any tick marks on there. So you would make an estimate that you think would be too low, about right, and too high. Let's think about this a little bit. Well, I know it cannot be 0. That's too low because 0 is right over here. So I don't think that could be it. I'm looking at my number line. I'm kind of guessing, maybe a half is somewhere in there. So maybe a fourth is too low. That's just kind of what I'm thinking. All right, let's move to about right. What would be an estimate that would be about right? Well, I said that I thought 1/2 was there. It's not exactly a half, but almost a half, right? So I can maybe suppose that that was one of the things that was about right. All right, let's go into the category of too high. 1 is definitely too high. I know my point is not over there. I could also think of some other fraction points that might be over there. 3/4 is somewhere over here. So that's too high. So that'd be an example of kind of estimating. We don't know exactly, but we can make some assumptions based on what we know about number lines and fractions. All right. There are 25 fractions in a table. Here's our lovely 25 fractions, and here's our little table they set it up onto. Okay. So identify the greatest fraction in each column. So this is the column right here going up and down. Let me highlight that for you. So this is A. So this is a column. This is a column. This is the column for C. Column for D. And a column for E. So, which one would be the greatest fraction? Well, I'm looking at column A, and I'm noticing that all of my denominators are thirds. So there's something going for us. So which one's the highest one? Which one's the greatest number? Okay. If you said 26 thirds, you are correct. We know that we're right because remember, we have to be prepared to explain our reasoning right here. We know that 26 is greater than 11, 7, 4, and 2. Because they have all the same denominators, we can look at the numerator and just know. All right, the greatest fraction, that's in column B. Oh, these are all fifths. So which one's the greatest? Well, let's see. I'm going to think about the same thing. If they're all the same pieces, and we're looking at the numerator. All right, so 26 fifths, because 26 is greater than 11, 7, 4, and 2. So I would go through each row, each column rather, and that's how I would decide which one's the greatest. Okay, so we did columns now. Now they want us to do rows. Think about if you're sitting at the movies, your rows would be going this way. You get to pick your row. So, starting with row 1. Ooh, which one's greater than? Now, instead of having all the same denominators, we have all the same numerators. But we know something about fractions and the denominators when they are different. We know that the larger the number for the denominator on the bottom, the smaller the piece. So I may have 2 pieces, but which 2 pieces do I want to have? That's going to be the greatest fraction. So looking at these, I would know that 3 is the smallest denominator for 2 thirds right here. So that would be the greatest amount. If I'm getting 2 thirds of something, that's more than half of the fraction. So I'd be doing pretty good. All right, same thing. Looking through here, all the numerators are the same. but the fractions on the bottom are different. So again, which fraction is going to be the bigger, the greater 4 pieces? The smaller the denominator, the bigger the pieces, the more you're getting, because we're assuming that all of these fractions are the same whole piece, just cut into different amounts of slices. Okay, so you'd go through those. All of them have the same numerator. You're just deciding which one would be the greatest one in each row. Now, for number 3, you need to decide which fraction is the greatest fraction in the entire table. What do you think? So 2/3, 2/5, 2/10. None of these are greater than 1. You know what I noticed? We have a fraction right here that's greater than 1 whole. Do we have any other ones? Oh, yep, we have this one too. And this one. This one's more than 1. This one's more than 1. This one's more than 1. Oh, these are definitely. So now we need to look at these fractions and decide which one's the greatest fraction. Well, there's a couple different things I could do. I know that it's just one more piece cut into thirds when I do 4/3. And I'm noticing that these are a lot larger on the top than the bottom. So we can easily think of what times 3 is going to get us as close to 11 as we can. Well, 3 times 3 equals 9. So it's 3 and a smaller fraction, a little bit left over, right? This one, how close can I get to 11? That would be like 2. But look at these numbers right here, 26. How many times 3 can we multiply by to get as close as we can to 26? I'm thinking of 8 times 3 equals 24, because 9 times 3 is 27. So that's like 8 and some change. That's some leftovers. Let's see, 5. What times 5 is going to get us close to 26? All right, so I'm thinking the largest fraction in this table is 26/3. That's almost 8 whole pieces plus a little bit more. Okay, so that's 12/1. All right, so here's the same table we saw earlier. Now you have some questions that you're going to answer about it. Which fractions are less than 1/2? So let's think about this. 1/2. When I think of 1/2, I know there's some equivalent fractions I can think of. So let's start with 1/2, 2/4, 3/4. No, not 3/4. Oops. 3/6. Sorry. 4/8, 5/10, 6/12. And I think that is pretty good there. Okay, so let's see. Which ones are less than 1/2? Well, we can tell which ones are 1/2, right? Because we know that. So we don't have a 50 over 100, so we can't do that. Do we have a 6/12 here? Nope. But we know if it's 6/12, then 7/12 is going to be higher than a 12. 11/12 is going to be higher than a 12. Half. And then 26/12 is going to be higher than a half. Okay. We also had 5/10 is what a half is equal to if we're doing tenths. So we know that 7/10 is higher. So these ones are higher. All right, what about, we don't have fifths. So, but if we think about what we got for these, this is higher than 1 whole, right? This one's higher than a whole. This one's higher than a whole. This one's almost 1, so that one can't be it. Okay, that one's higher. This one's higher than 1, greater than 1, greater than 1, greater than 1. And that one is more than a half. Okay. So once we've done this, we can say, I know a fraction is less than half when, what do you notice? What do you notice about our table here? We notice that a fraction is less than 1/2 when it's not half of the denominator. We could say that. So for example, if it's half of the denominator, for example, 5 is half of 10. Okay, which are greater than 1/2 but less than 1? So we kind of talked about that as we were going through those steps. Like for example, 7/10, we knew 5/10 was 1/2. So 7/10 would definitely be more than 1/2. Okay, and then you would just color the remaining fractions with a pencil or draw a square around each one. And then think about where they fit in the scheme of things. Are they greater than 1/2, less than 1/2, greater than a whole, more than 2? Think about what connections you're seeing there. Okay, our last page. Next to the table, create a legend or a key that shows what color or each shape represents. So let's go back to that table. So if you colored in, let's see, oh, I wish that I hadn't, oops, nope, that's not what I want. I wish I hadn't erased that. We kind of could have used that. I don't know if we can now. I don't think we can bring it back. But anyway, so we had like this, almost looked like a staircase thing going on here. So maybe you would color in the ones that are less than 1/2 in green or blue. So the ones that you color in that are less than 1/2, you could say less than one-half. And then you would color in anything that's less than a half. So for example, 2/5, we would color that in purple. 2/10, we would color that in purple. 2/12, we would color in purple, and so on and so on and so on. Then you could say equal to 1/2. I don't think we had anything equal to 1/2 from what I can see. So we could do, oops, a different color. And we could say that is greater than 1/2. Let's see, that was this. And then we could say maybe greater than 1. Oops. So you can color this however you want. That's kind of up to you with what colors you use and stuff. Just make sure that you're using some kind of criteria that it's greater than, less than, more than 1. So just make sure that you show next to it a legend or a key shows what color means what on your graph. Okay, and then you're just looking at some fractions over here and you're trying to decide which one is greater. Is 2/5 greater or 7/10 greater? How do you know? You could do a number line, you could do some division or some multiplication if you need them to be equivalent fractions that have the same denominator. So whatever strategy you want to use on this, you may use. Okay, let me know if you have any questions. Thanks.